And this is about analytics optimization or operations research optimization. The kind of optimization that helps you determine what is the right price to sell my product and also the right cost to create my product. So let's have a look at the core fundamentals. What is optimization? Why do we need it? Where is it implemented? How do we develop it? And when to use and when not to use optimization. So let's start with the basics. Analytics. So I see there are 4 different types of data analytics. The first one being the descriptive, which tells us what is happening in my business. So low on value, low on complexity. It's like reports, dashboards, etc. Then you have diagnostic analytics, which helps you explain why is this particular thing happening in my business. So it cannot exist without descriptive analytics. It's more or less like root cause analysis. Then the next level would be predictive analytics, which explains what is likely to happen in the future based on historical data. Now, again, predictive cannot exist without the two mentioned analytics before, but more on value and more on complexity. And then the next level is the advanced analytics or the prescriptive analytics. Now, in order to know what do I need to do for the next upcoming crisis, I need to know what is going to happen in my business, why is it happening, what's likely to happen in the future. So I cannot prescribe a solution before I know what is wrong in my business. Now let's double click on advanced analytics and see what are the different types of categories. One very popular category is AI, ML, NLP, right? But I would like to, I know I don't need to define what is AI, but I would like to define it as or describe it as identifying patterns and using those patterns to automate simple decision making. Another kind of category within prescriptive analytics is optimization, and that's the focus for today's presentation, where we use mathematics to optimize for complex decision making. Now, I'm not saying that optimization is better or worse than AI, but it is certainly different than AI. And I see many different use cases where both optimization and AI play an important role and they work in sync with each other. So let's double click on optimization and see how do we define optimization. And I see 3 different components which make up optimization. These are variables, constraints, and objective function. And in order to understand what are these 3 different components, let's take a few daily use case examples. The first one is investments in stock market. I would say it's a pretty common use case. Many of us might have already done this before. But what are the different types of data that you need to invest in or data that you need to get before you start investing, right? So one of the most important kinds is your historical trends, historical data information of every stock. And then you also need to understand how volatile or how risky are these investment opportunities. And then you need to understand what are the macro and microeconomic factors that are going on in my globe. And probably you can use an AI-based tool for a much better forecasting than your standard regression analysis. You can use AI to read all over the internet and provide a much better forecast of how a stock is likely to perform in the future. But then you also have your constraints. Your constraints like, I have a limited budget. I don't have unlimited money to invest in stock market. How should I use and allocate my funds in the most optimal way? Another kind of constraint that you could have is that I don't want to invest in one type of stock or one type of domain all the time. I want to invest in FMCG, also in manufacturing, also in tech, right? So I want to diversify my portfolio. But your overall objective function remains that I want to minimize my risk and I want to maximize my profit. And if you feed all of these information in an optimizer or a solver, it can look at your budget, look at your constraints, and allocate your budget for minimum risk and maximum profit. So I hope this makes it clear what are variables, constraints, and objective function. But in order to understand more, let's take another example. And this is a pretty common example. Just before the summers, we are always trying to plan where should I plan my next vacation or where should I go next. Let's take Italy, for example. And this is a pretty common use case also for AI. Today, if you ask ChatGPT, I want to go to Italy for a vacation, what should be my itinerary? And AI can read all over the internet and provide you a very nice itinerary based on your number of days, how should you plan your vacation, right? But what ChatGPT cannot tell you is how to create a budget-friendly vacation or how to minimize my costs at the same time. In order to do that, you need database of all the flights and hotels and attractions, right? And you can probably get that also in a company like Booking.com, where an aggregator company would be sitting on these kind of data sets, right? Probably Booking is already working in this direction and creating a AI chatbot for you. But then you also come across your constraints. Your constraints, like I have my maximum number of vacation days. I cannot take more vacation than my initial estimate. I have a date range in which I want to take my vacation. And then I have my must-see visits. Like I definitely want to go to Rome. I definitely want to go to Florence. These are my must-see. I cannot skip them. But your objective function remains the same, to minimize your total cost in your vacation. And if you feed, again, all of this information in an optimization engine, it will take all the travel permutation combinations in one go. It will possibly understand whether you need to fly into Milan and fly out of Naples, or fly into Naples and fly out of Venice, whether you need to stay in Rome for the weekend or Venice for the weekend. It will take all of these permutation combinations and give you a nice, balanced, cost minimal vacation itinerary. So I think this gives us a flavor of how optimization works. But let's also see why is it used in big companies. Because in my previous example, one could also say that I don't have hundreds of permutation combination. I only have a couple. Why do I need an AI chatbot for it? Or maybe 900 euros versus 1,000 euros, 10% savings here and there doesn't really make a difference, right? So all very fair points, and which is why for B2C use cases, the use cases are limited for optimization. But when you take an enterprise, a company, then the use cases expand, because every 1% optimization can in turn save you millions of euros, right? So let's take a look. Let's have a look on how big companies would be using it. I see two important use cases, which is my cost minimization and my revenue maximization. And when I say cost minimization, I mean the total manufacturing and supply chain costs of creating a product. So what is my right cost to serve my products? If I look at a very standard supply chain, it goes from factories, suppliers, to the distribution centers, fulfillment centers, and then to my customers. Now the tricky part is, where should I set up my distribution centers, fulfillment centers, and how many should I set up, right? Let's draw a graph between cost to serve and time to serve. And you will get a bell-shaped diagram. And this would probably take you back to your school mathematics days, where we used to explore differentiation and integration for global minima, global maxima. Optimization works on similar concepts. Optimization would, let's take an example and see, if I keep my distribution centers closest to the customers, like Amazon Prime, like next day delivery, I would have many distribution centers all over my European network, and my warehousing costs would shoot through the roof. So I will end up with a higher cost to serve. On the other extreme, if I keep them far away and I keep only one distribution center for the entire Europe, or maybe none, I would save on my warehousing costs, but my transportation costs would be expanding at an exponential rate, right? Because I need to travel longer distances to serve my customers. So both of these extremes are not the best cost to serve. The best cost to serve lies somewhere in the middle, where you have the lowest cost to create and serve my product. So this use case is not only for distribution, but also for manufacturing. Whether I should have a centralized supplier, or I should have many small different suppliers all over the globe, right? So these kind of decisions are mathematically taken by big companies in order to save costs. Now that we know what is my right cost to serve, we should also see what is the right price to sell my products. And again, we draw a diagram between the revenue and the price, and we draw a graph, and we again see a bell-shaped diagram. Because if we keep a very low price, we will see let's say a standard product, non-luxury, if you keep a very low price, you will get higher sales. But at the end of the day, you will still get a lower revenue because you kept a low price. If you keep a very high price, you will get fewer customers, and so your revenue still remains low. But if you keep your price somewhere in the middle, you keep your price optimal, you'll get medium sales and medium conversions, and then you will have a much higher revenue. So this is not a new thing which companies are doing. This is something of a very standard practice that retail and e-commerce companies are doing as their pricing optimization. What should be my price of the product and how much discounts I need to give, whether it's 10%, 20%, 25%. All of these is mathematically calculated using optimization. And let's take a look now at some very popular use cases. Some companies, how they will be using this kind of an optimization. For example, Booking.com would be using optimization to dynamically set their prices and set their discounts to consume their inventory. On the other hand, Google Maps or Waze would be using optimization to find the most minimal transportation time or minimal time from point A to point B. And combining these two would be something like Uber or Bolt, where you would also use it for routing and pricing optimization. On the other hand, you would have entertainment industry like Netflix OTTs or Meta social media giants, where they would be using optimization for recommending the best advertisements and the best content for their consumers, so that it's also not very repetitive, but also leads to higher conversion rate. On the other hand, as we discussed, supply chain and manufacturing have a lot of use cases for optimization to ideally decide what is your manufacturing and your distribution footprint, like Adidas, Amazon, PepsiCo are some key names. Similarly, as we discussed about investments, investment banks and financial institutions would be using it to decide what is my most optimal investment allocation. Big consulting companies like McKinsey would be using it to optimize your resource allocation. They would be sitting on a huge talent pool of people and also a huge backlog of projects. But every project has a limited budget and has a timeline. So when should I start which project, and who should be working on these projects? This is all mathematically calculated for such a large scale as McKinsey. Now that we know what is optimization, why is it needed, and where is it implemented, we should also understand, since we are in a dev conference, we should also understand how to develop optimization. And there are two ways to go about it. First is either we can directly buy these optimization softwares, these products from the market. I'm very close to supply chain domain, so I know what are the major players that exist in this domain. But I'm sure that there are also key players in investment optimization, pricing, resource, campaign optimization, etc. And maybe just a call out, if we are not yet ready to invest in a big product right now, you can also take use of Excel solvers, which would be available at your disposal. You can use these for running proof of concepts, MVP approach, before going and buying a product from the market. Or alternatively, you would want to develop this capability in-house in your company for your specific niche use cases. And for that, you can start with Python or standard libraries. You can start by hiring skilled developers who are also specialized in operations research, analytics, PhDs, etc. Or you could also start with data scientists, skilled data scientists. But at the same time, you also need one more flavor, which is external mathematical solver plugins. Now, I have listed down these two companies, Cplex and Gurobi, because they have the biggest market share for creating such plugins, which you can directly integrate with your product and solve your optimization use cases. This is because we are not changing the core fundamental concepts of analytics. We are not changing variables, constraints, objective function. What we could have is our own custom mathematical equations, but at the end, we still want to use analytics to solve it, right? So it's a good idea not to recreate the wheel, but to integrate these third-party solvers with your product. Now that we know how to develop, before going inside development mode, as product managers, as product owners, we should take a step back and think about what is my use case and do I actually need optimization for my use case? Because like every other technology, optimization has its pros and cons. The pros being most optimal solution, global optimization, taking all your variables and constraints into one go. But on the other hand, you have disadvantages like huge runtime. For example, the product might take 1 hour to reach from 0% optimization to 90% optimal result, and take another 1 hour to reach from 90% to 100%. But then you need to think about, is it really worth it? Is double my runtime really worth that extra 10% optimal result? Sometimes probably yes, sometimes not. Another disadvantage I see is difficulty in getting root cause analysis, and it acts sometimes like a black box, also comparable to what complaints we have for AI and LLM models today, where we know that this is the most optimal result, but why my preferred option was not selected? Why was this selected and not the other one, right? This is a little tricky to find in optimization, and if we don't have this RCA, it's also then harder to debug. So if runtime or RCA is my biggest concern in my business, then probably optimization is not your best friend. But if your concern is more about your optimal result, every 1% optimality matters for you, then we should go for optimization. Alternatively, we also have another approach similar to optimization, which is called heuristics, which is like a step-by-step approach, basically how all the flow charts and algorithms work today. You can use that if runtime and RCA are your biggest bottlenecks in your business, in your use case. But I'm not going to go much inside heuristics, but if you are interested and if you want to talk about it, I am available after the demo. Let's talk and let's connect. Taking a step back, optimization can unlock huge opportunities, huge scope for you. But before going into development mode, we should think about what it is that we are trying to solve and what is the limitation that the business is ready to accommodate. And I would like to conclude by contrasting between AI and optimization, saying that AI explores the realms of possibilities, whereas optimization charts the most efficient path within. And this is said by a very famous author, our very own ChatGPT. Thank you, everyone. I hope you learned something today. Let's connect after the demo.